It was in 1960, deep within a limestone cavern on Katsika Hill in northern Greece, that one of the most perplexing skulls ever discovered in Europe came to light. Known to paleoanthropology as the Petralona cranium, this fossil, embedded in the mineral-streaked walls of a cave nicknamed the Red Rock Cave, would go on to challenge the very structure of the human evolutionary tree. As a specimen of the Middle Pleistocene, it has been dated to around 375,000 years ago, situating it within marine isotope stage 11, a warm interglacial period that gave rise to flourishing ecosystems across Europe and an opportunity for hominin expansion northward from Africa. The Petralona skull is both hauntingly familiar and strangely alien. Its brow is a heavy torus, prominent and robust, yet internally hollow, a feature that distinguishes it sharply from both modern Homo sapiens and classic Neanderthals. This hollowing of the browridge was later found to be filled with extensive frontal sinuses, and it is this feature, among others, that positions Petralona at a fascinating crossroads between primitive and derived traits. While its massive upper face and browridge evoke the brutishness of Homo erectus, its vault and endocranial volume suggest a species on the cusp of becoming recognizably human. Its resemblance to the Kabwe skull of Zambia, another enigmatic fossil dated to a similar range, underscores the notion of a widespread Middle Pleistocene population that straddled the evolutionary boundary between Homo erectus and Homo sapiens, and which may have included the ancestors of the Neanderthals. The fossil was found in a cave near Thessaloniki by a local shepherd who, driven by curiosity, led villagers to clear the snowy entrance. What they uncovered was not just a geological marvel rich in stalactites and stalagmites, but also a prehistoric vault containing traces of fire, tools, and the haunting stare of a fossilized cranium staring outward from the limestone. Though the jaw was missing, the skull was otherwise remarkably preserved. Initial dating placed it at around 200,000 years, but subsequent stratigraphic analysis, animal fossil correlation, and modern techniques have raised the estimate to between 350,000 and 400,000 years. Based on associated faunal remains and geological stratigraphy, the most widely accepted date today lies close to 375,000 years ago, an age that aligns it with marine isotope stage 11, one of the warmest and longest interglacial periods of the Pleistocene. This timing is critical. The interglacial warmth allowed temperate forests and grasslands to spread across southern Europe, creating ideal conditions for hominin occupation and migration. The Aegean basin, where Greece lies today, was then largely exposed as dry land, forming a natural corridor between Anatolia and Europe. Petralona's position at the geographical gateway of Europe reinforces its importance as a possible staging ground for early Neanderthal evolution. The internal structure of the Petralona browridge is perhaps its most curious feature. While all early hominins have some form of supraorbital torus, in Petralona the entire structure is hollowed out by massive frontal sinuses. These air-filled spaces reduce the weight of the skull, while possibly serving functions in vocal resonance and temperature regulation. More provocatively, some researchers have suggested that such features might serve a social function, allowing for more expressive facial gestures or enhancing masculine traits in sexually dimorphic signaling. Hollow browridges are rare even among robust archaic humans. In modern Homo sapiens, the browridge is generally vestigial, and the frontal sinus, if present, is much smaller. In Neanderthals, the brow is solid but pronounced. The Petralona configuration, massive, projecting, and internally pneumatized, may thus represent an adaptive compromise, retaining the facial architecture of earlier forms while internalizing structural changes related to cranial reorganization and encephalization. The sinuses, therefore, are more than evolutionary footnotes. They are anatomical witnesses to the reworking of the skull from the inside out during a critical phase of human development. The Petralona skull is more than a curiosity of the fossil record. It is a keystone in the bridge between Homo erectus and later hominins, perhaps even an early Neanderthal or a distant cousin of modern humans. With its distinctive hollow browridge, it forces us to reconsider not only the structure of the face, but also the evolutionary pathways of sinus development, brain expansion, and cranial morphology. Found in a region that served as a corridor between Africa and Europe during one of Earth's most stable interglacials, Petralona may preserve the face of an ancestral population from which Neanderthals and perhaps even modern humans arose. New discoveries continue to enrich and complicate our understanding of early European populations. The Petralona skull, long regarded as the most complete mid-Pleistocene hominin cranium in southeastern Europe, now finds itself in dialogue with another fossil discovery from the same region, the Apidima crania, excavated from a cave system in southern Greece. These fossils, particularly Apidima 1, have reignited debate over the timing and direction of human migration and the complexity of early hominin lineages in the region. The 2023 study, The Complex Picture of the Chibanian Hominin Record at the Crossroads of Europe and Asia, situates both Petralona and Apidima within what is now termed the Chibanian period, a geological stage equivalent to the Middle Pleistocene. The research stresses that the Balkan Peninsula, and Greece in particular, was not a marginal outpost, but a dynamic biogeographical corridor linking Africa, Asia and Europe. It was a land of overlap and interaction, where different hominin lineages may have coexisted, competed and possibly interbred. Apidima 1 is a particularly striking case. This partial cranium, dated to over 210,000 years ago, is described as showing a blend of traits inconsistent with both Neanderthals and classic Homo erectus. Instead, it has been controversially interpreted as a possible early Homo sapiens. If this holds, Apidima 1 would represent the oldest Homo sapiens fossil yet found outside Africa, a proposition that, if accepted, would push back the timeline for early modern human dispersals into Europe by more than 150,000 years. Placed side by side, Petralona and Apidima 1 offer an intriguing contrast. Petralona is older, more massive, and more clearly affiliated with a European lineage evolving toward Neanderthal morphology. Apidima 1, in contrast, appears more gracile, with a rounded, modern-like occipital region, and no trace of an occipital bun or prominent browridge. It lacks the mid-facial prognathism and double-arched browridge of classic Neanderthals. While the fossil is fragmentary, it has been described as morphologically closer to early modern humans than to any known Neanderthal. Apidima 2, found in the same cave complex but at a later stratigraphic level, tells yet another story. It dates to roughly 170,000 years ago and does appear to possess Neanderthal features, particularly in the browridge and mid-face. Thus, within a single site in southern Greece, we find two very different hominin morphologies separated by 40,000 years. One appears to be early Homo sapiens, the other a Neanderthal. These findings suggest that Greece was not merely a place of linear evolutionary progression, but rather a crucible of interaction. The Petralona skull, in this light, may represent an earlier, more basal branch of the local Neanderthal lineage, an offshoot retaining erectus-like traits, but already diverging toward the Neanderthal adaptive pathway. Its robust brow, massive facial bones, and internal sinus architecture support this interpretation, linking it closely with other Middle Pleistocene fossils like Kabwe and Jebel Irhoud, yet still distinct in both geography and morphology. The marine isotope stage. 11 interglacial period, during which Petralona likely lived, was among the warmest and most stable climate intervals of the Pleistocene. In Greece, this climate created conditions that would have supported a variety of large mammals and allowed hominin populations to occupy coastal and upland zones year-round. Fossil pollen and fauna from nearby sites suggest oak and beech forests mixed with grassland, and the presence of horses, deer, rhinos and bovines. The absence of glacial stress meant populations like Petralona could thrive without being forced into southern refugia. Petralona's age places it within marine isotope stage 11, a warm interglacial period lasting from roughly 424,000 to 374,000 years ago. Marine isotope stage 11 is often considered the best analogue to the Holocene due to its length and relative climatic stability. In southern Europe, this meant an abundance of plant and animal life, mild winters and wide corridors for migration. The Aegean region, much of which is now submerged, would have been a lush lowland connected to Anatolia by dry land. Greece, as a passageway between continents, was thus in a prime position for the diffusion of hominin populations. The Petralona cave itself may have served as a seasonal shelter or permanent dwelling. Excavations have uncovered fossilized wood, animal hair and stone tools, indicating repeated or prolonged use by human groups. The abundance of large herbivore bones in the cave layers hints at a meat-rich diet, which may help explain the powerful jaw and musculature inferred from the skull. Furthermore, stone and bone tools have been found in close stratigraphic association with the fossil, indicating that whoever this being was, he or his kin were tool makers capable of exploiting the environment in a distinctly human way. Yet these stable conditions may not have lasted. By the time Apidyma I arrived, perhaps as a wave of Homo sapiens advancing from Africa or the Levant, ecological conditions may have become more fragmented. The fossil evidence from southern Greece now suggests repeated hominin occupations over hundreds of thousands of years, interrupted by climatic instability and competition between species. In this way, the Petralona individual may represent not just an ancestor to Neanderthals, but a member of a regional population that predated and perhaps even interacted with early Homo sapiens groups, such as the one represented by Apidyma I. If so, this would profoundly affect our understanding of how these early populations met, merged, or displaced one another. Petralona's evolutionary position becomes even more complex in light of the Apidyma finds. If early Homo sapiens were already moving through the region by 210,000 years ago, the classic out-of-Africa narrative must be revised to incorporate pulses of migration, some of which may have failed, others which left genetic or cultural traces in local populations. The Middle Pleistocene, far from being a time of static regional evolution, was one of dynamic interchange. Petralona, then, might not represent a direct Neanderthal ancestor, but rather an early, regionally adapted hominin within a fluctuating population system. It could represent a ghost lineage, a genetic offshoot that contributed elements to later Neanderthals or was eventually absorbed through introgression into more modern populations. This possibility is supported by recent discoveries of complex population structure in ancient DNA from Cima de los Huesos, which reveal a tangled family tree for European hominins stretching back over 400,000 years. In terms of morphology, Petralona aligns with other pre-Neanderthal specimens like those from Arago and Sacco Pastore, but remains distinct in size and internal architecture. Its hollow browridge remains an enigma, an anatomical innovation seen neither in Apidyma nor in classic Neanderthals, and possibly indicative of local adaptation or unique developmental pathways. Whether this trait had functional, thermoregulatory or sexual display purposes remains an open question, but it is further evidence that Europe's ancient inhabitants were experimenting with a wide range of anatomical solutions to the pressures of their environments. With the Petralona and Apidyma fossils now considered together, a revised picture of southeastern Europe begins to emerge, one that challenges linear or tree-like evolutionary models. Instead, what we see is more akin to a braided stream, with different hominin types coexisting, crossing paths, and perhaps even interbreeding. The region acted not only as a corridor, but as a collision zone for diverse evolutionary experiments. Petralona belongs to this story not merely as a relic, but as a dynamic participant. Whether it represents a transitional Homo erectus Neanderthal, an early archaic Homo sapiens, or a unique regional form, it reveals how deeply entangled human evolution was across continents. And when paired with Apidyma, especially Apidyma I, the possible early modern human, we are faced with the stunning possibility that southeastern Europe witnessed multiple overlapping human migrations, starting much earlier than once believed. If Apidyma I was indeed an early Homo sapiens, then Petralona may represent a parallel lineage that existed in Europe before being supplanted or absorbed. Or perhaps the situation is more complex still, where hybridization, climate oscillations and shifting ecologies allowed for intermittent dominance of one lineage over another. In light of new findings at Apidyma, The Petralona skull's importance has only grown. Once regarded as a singular example of early Neanderthal development, it now stands as a node in a complex web of hominin evolution in southeastern Europe. Its heavy, hollow brow, massive facial architecture, and distinctive sinus pattern mark it as both archaic and advanced, regional and transitional. With apidema, one potentially extending the presence of Homo sapiens in Europe back over 200,000 years, the notion of a clean unidirectional migration from Africa to Europe falls apart. In its place emerges a vision of ancient Europe as a mosaic of populations, some evolving locally, some arriving in pulses from Africa or Asia, some vanishing without a trace, and others merging into the lineages that would eventually become Neanderthal or sapiens. Petralona, with its mix of erectus, Neanderthal and perhaps even sapiens traits, was not an evolutionary dead end. It was one chapter, perhaps even one of the earliest, in the story of who we are. As we continue to peel back the layers of sediment, bone and time, it will likely remain a key fossil in unravelling not just European prehistory, but the shared heritage of all humankind. The Petralona cranium defies easy classification. It has been variously labelled Homo erectus, archaic Homo sapiens, and most recently Homo heidelbergensis. Yet none of these designations fully capture its mixture of features. Its cranial capacity exceeds 1,200 cubic centimetres, which is comfortably within the range of early Neanderthals and modern humans. The skull is thick-boned, and the face is especially massive, particularly across the cheekbones, orbits and palate, while the cranial vault has a reduced occipital torus compared to more primitive forms, indicating a move toward the derived condition seen in later species. It is the browridge, however, that draws the most scientific intrigue. The supraorbital torus projects heavily, arching unbroken above the eye sockets, but X-ray imaging and CT scans have revealed it to be largely hollow, housing an expanded frontal sinus. This hollow browridge serves multiple potential functions. One possibility is that it helped reduce the weight of the massive facial structure without compromising its strength. Another is that it provided a structural framework for the frontal sinuses, which may have played a role in thermoregulation, vocal resonance, or even social signaling. The extent of pneumatization, the process by which sinuses expand into bone, in Petralona far exceeds that of the Kabwe skull. In Kabwe, the frontal sinus was well developed, but in Petralona it spans the entire breadth of the browridge, suggesting a morphological innovation that might have facilitated neural, respiratory or perceptual adaptations. These sinuses, perhaps more than any other internal feature, mark Petralona as distinct from classic Neanderthals, who also had well-developed sinuses, but distributed differently. Indeed, sinuses have now been recognized as critical features in distinguishing hominin species, especially in the Pleistocene, where they show correlations with brain expansion, facial morphology, and even dominance of one hemisphere of the brain over the other. Perhaps no comparison is more fruitful than that between the Petralona and Kabwe crania. Discovered in 1921 in what is now Zambia, the Kabwe skull, sometimes called Rhodesian man, shares many anatomical affinities with Petralona. Both specimens have a robust build, pronounced browridges, thick vault bones and broad faces. Their cranial capacities fall within a similar range, and both show features suggesting a transitional phase between Homo erectus and more advanced human types. They are considered by some researchers to be part of the same evolutionary grade, even if not precisely the same species. The Petralona skull is generally seen as more advanced cranially, particularly in the rounding of the vault and the reduction of the occipital torus. Facially, however, Petralona may be more primitive, with broader orbits and a more massive maxillary region. The two may represent geographically separated populations of a single widespread Afro-European lineage that existed before the divergence of modern humans and Neanderthals. Indeed, both skulls have been suggested as candidates for the last common ancestor of Homo sapiens and Homo neanderthalensis, especially if that divergence occurred around 400,000 years ago, a time frame supported by genetic evidence from the Cima de los Huesos fossils in Spain. The Petralona fossil has had a long and tortuous history of classification. It was initially labelled as Homo neanderthalensis due to its heavy brow and robust features. Later, its more primitive cranial elements prompted a reclassification as Homo erectus. In recent decades, many paleoanthropologists have settled on Homo heidelbergensis as the best fit, though even this is contested. A number of experts argue that Homo heidelbergensis is an artificial taxon, a catch-all term for mid-Pleistocene fossils that don't fit neatly into other boxes. Some prefer to consider Petralona as archaic Homo sapiens or as an early European Neanderthal with residual erectus traits. This is not merely a semantic debate. If Petralona is archaic Homo sapiens, it undermines the strict version of the out-of-Africa theory, which holds that Homo sapiens evolved only in Africa before spreading to Europe. A 375,000-year-old archaic Homo sapiens in Europe would force us to re-evaluate timelines and migration models. Additionally, Petralona lacks several traits considered diagnostic of classic Neanderthals. The face is flatter in its mid-region, the orbits are smaller, and the nasal aperture is not as projecting. In cranial metrics, it is closer to Kabwe and the Jebel Irhoud skulls of Morocco than it is to later European Neanderthals. These distinctions support the idea of a long, gradual process of Neanderthal evolution in Europe, with Petralona representing a very early stage in that lineage, possibly even a side branch. Its resemblance to the Kabwe cranium, found thousands of miles away but sharing key morphological features, reminds us that evolution is rarely tidy. Populations diverge, converge, migrate, and hybridize across continents and millennia. In the Petralona skull, embedded in a quiet Greek cave, we glimpse not just the anatomy of an individual, but the ghost of an entire evolutionary narrative, one still unfolding with every new fossil, every fresh genomic sequence, and every challenge to orthodoxy.